You're watching Meet the Astronomers on Astraveo.
Hello there. Welcome to Astroveo's Meet the Astronomer series, where we talk about the most interesting parts of astronomy, the people. We're going to meet and greet a whole slew of people doing the actual work in astronomy. We're talking instrument builders, telescope operators, professors, early career scientists, postdoctoral researchers, program managers, and citizen scientists. This is absolutely fascinating for me and Joseph because we get to meet a vast array of people on our travels when we go to telescopes or conferences. We meet people from different cultures who speak different languages, who eat different foods, and sometimes grew up seeing different stars than we did if they lived in the Southern Hemisphere, for instance. So this is a lovely, lovely series. We're going to really get to meet some thoroughly interesting people. We're going to hear some stories that will make you laugh, some that might make you cry, but most of all, they'll make you realize the absolute fascination that the human race has with astronomy and its astronomers. All right, let's get started.
Well, hello there, Stephen. So before we get going, I would like to show our viewers your office, which is full of all kinds of toys, mostly sci-fi, and you're a guy after my own heart. So would you like to introduce us to some of your toys in your office here?
Yeah, well, first of all, they are collector's items.
I apologize.
So yeah, I have a lot of different eclectic things in here. Science fiction, IPs, but also a lot of dinosaurs.
Is that it's almost like the Scorpion King Scorpion, I like that.
Yes.
Okay, I'm going to show, look at that, the TIE Fighter helmet, super cool. Oh, you've got the General Lee, you've got Herbie. Oh my gosh, this is super cool. So I love you've got all the science books, all your sort of astronomy books. Ooh, I like that. You've is that the ATST?
ATST, yes.
Nice. Very nice.
That's a TIE Interceptor.
A TIE Interceptor, there you go. That's sort of Kylo Ren's ship, right?
No, those were used in kind of the Jedi.
Oh.
Yeah, so it's more advanced.
So 1983.
Wow. Yes.
Okay, so I'm just going to do a sweep more because Stephen has his items over here. Got a really cool mural. Must be a star-forming region. Maybe. There is some interstellar gas and dust in the Pleiades, but I don't think it's that much.
It does look like it.
It does, I agree. And then you've got a lightsaber, very nice. You've got this old Apple Mac. God. You've got the arcade games. Oh my gosh, you know, we should not do this episode. We should just play your arcade games, of course, Robocop, love it. You've got various exciting telescopes. Oh, looks like the old INT there, maybe. Oh, very nice. And then you've got all these characters. Oh my god, my kids would love this. Oh, is that Inspector Gadget?
It is.
I love that. Did you do it?
Yeah. Don't start the piece, I'm going to spray my hair for the next 2 minutes.
Okay, well, we don't have to look at the what looks like rum bottles. And this looks like a Gallagher.
Yes, Gallagher. Yeah, it's a lenticular.
Oh, I love it. Oh yeah. Oh, I see it now. Yep. Oh, so cool. Oh, and there you go. We got this the original Star Trek Enterprise. Okay, well, super cool. So I just wanted to show our listening viewers, all three of them, your really exciting office. So, okay, well, we'll get down to the main part of the tour. Thank you for that. Welcome to Riverside, California, where I am sitting with a very good friend, Dr. Stephen Kane. This is a Meet the Astronomers episode, so this is a real-life astronomer. Stephen, I met first in astronomy in 97, 98 in St. Andrews.
2001.
It was 2001.
That's when I moved to St. Andrews.
Oh, not better memory. And obviously we disliked each other immediately. We just used to tell each other silly jokes at tea time.
Or very silly jokes.
Very silly. But yeah, you've been a friend and colleague for a long time, so thank you for doing this.
Oh, my pleasure.
It's a complete privilege for me, thank you. We're going to talk through our usual questions that we give when we do meet the astronomers. But I'm going to quiz you on a few astronomy things because for our 3 listeners out there, Stephen is a world expert in exoplanets and exobiology, planetary atmospheres, specifically with a tint of Venus. So we're going to get a
very strong tint.
Very strong tint, actually. Yeah, you've been Venusian for quite a while, actually.
I have, yes. Cythereans, we call it.
Do you really?
Yeah. Cytherea is a word that means pertaining to the planet Venus. So yeah. Where
does that come from?
I don't know.
I
was going to say Greek, but it's probably Latin. I don't know.
Well, you should know this with your children. I said to my children, you should never use a word you don't know what it means.
Oh yeah, fair enough. Well, I know what it means. I just don't know
that's true.
The Latin roots.
You don't. So this is going to be really fun. It's actually a real pleasure for me because I've not seen you for 9 or 10 years.
It's been a little while.
It's been a wee while, and we discussed that we got saw each other at some conference or other in. It was either in Arizona or in Baltimore.
I think Baltimore, actually. Now that you say that.
Do you remember which conference it was?
No idea. No.
Well, it's been a while, so.
Yeah, ships are passing on.
Ships passing on. So Stephen is a full professor here at the University of California, Riverside, where he moved, 9 years ago, maybe? Something like that?
Yes, 2017.
So, and he's got a research group. I met your graduate students today. They're a fun bunch.
Yeah, they are.
And you have this amazing office, which we're going to insert some videos so everyone will get to see it, with some really interesting collector's items.
Thank you.
I got told off for calling them toys. I don't think we looked at the 2 Star Wars images, the Escape from the Death Star and that's a space station.
It's inevitable there'll be some things that we probably miss.
I'm going to take a picture of it probably, but...
Fair enough.
Okay, well, let's get into it, because I know you pretty well, but if you have any secrets, they're all coming out.
Oh, great. I'll brace myself.
And I know the answer to this, but I'm going to see how far you go with it.
All right.
Where did you grow up and where are you from?
So, I am originally from Australia, and I grew up in Outback Australia, in a small town called Tamworth, which is the country music capital of Australia. And it's sheep stations, and past a boundary now where I've lived longer in the US than in my home country, which I feel very conflicted about. But yeah, so
when did you leave Australia?
The first time I left Australia was in 1996, and that's when I started grad school in Baltimore. Yeah.
Oh, you enjoyed Hopkins?
I was actually part of an international graduate student fellowship program that was hosted at Space Telescope Science Institute. Yeah, well,
that's pretty cool. So you and I joked about this when we first met, is because I have been to Tamworth several times, because it's sort of on the way to the what is now the Australian telescope. It used to be called the Anglo-Australian telescope.
Right, that's where you got a speeding ticket.
Thank you for bringing that up, Stephen. Actually, I got a speeding. Well, it was more than a speeding ticket. That's just north of.
Oh, you mean in South Australia? You talk about Cooperpedia area?
Yeah, south, but there's a P maybe. Oh, it's a pretty big town.
No, I'm blanking on it now too.
That's bad. Food and culture. What was that like when you were a kid growing up?
Yeah, that was interesting. It was quite basic. I grew up in a very working class family, and so the culture was very much what you might expect of rural Australia, which is that weren't particularly interested in school. You know, they wanted to go out into the workforce, to work on their parents' farm. They were just trying to get out of there as soon as they could. And myself, in the meantime, was asking all of these questions that the school career counselor had never heard before, which is, how do I become a professional astronomer? You know, So it was an interesting cultural background in which to go through that process.
Well, I felt the same growing up in Wales, where you're the odd person out, because essentially, at the age of 7, I told my mother I wanted to become strong. I want to know why they twinkle, or why they're different colours.
Well, for my family, like I said, they're very working class, and their children are concerned, are primarily interested about them growing up and getting a job, that sort of thing. When you tell them, "Oh, I want to be an astronomer," what they like, they are fairly confident that you will be unemployed.
Yes. Well, I mean, obviously you were too young, but the astronomical community in Australia is quite well developed, actually. That's similar to science.
Yeah, I mean, and there's a lot of reasons why I became interested in astronomy. I did go out and visit Coonabarabran. There was a school trip there when I was about 11 years old. And
did you go to the mountain, or was it?
Yeah, we got to visit the telescope, the viewing room for the 3.5 meter Siding Springs telescope. Yeah, it's 3.9 meter, and the night skies were glorious. Because I lived on a farm outside of town, and it was just incredible dark skies. More direct view towards the galactic center, so you see the Magellanic Clouds.
It's magical for anybody, even if you're a child when that happens. Did my first observing trip proper was to South Africa. Although I can still a kid, but all the way up there, and of course, you know yourself when you do your PhD work, you need observations, or if you're in our field, you need actual photons on the detector. All the way up there, rain. Oh God, I'm never going to get a PhD. And we got there, and we had a telescope operator, which we ended up calling Maverick Gordon, because it was raining, and you could hear the rain on the 3.9 meter, or the old AAT. And so we'd hear you could hear like inkling away on the go. And it does remember the old AAT, it hadn't and the slit would move. Observing my PhD stars through a hole in the clouds. Oh my God, I'm not getting a PhD. It's like, quick, observe! Right? Have I got enough data to get a PhD?
Well, that's amazing.
Okay, well, we still answered the next question too, and you and I think, had very similar experiences.
Was during the 80s, that's when we were doing a lot of our exploration of the outer solar system. So the Pioneer spacecraft had flown through the outer solar system prior, but in 1986, Voyager 2 flew past Uranus. And I remember watching the images coming back from JPL of that flyby. And I was just struck by, we're seeing an alien world. And again, in 1989, when we went past Neptune, left a very strong impression on me as well. Yeah.
My mother, when I was about 7 or 8, as I said, told us to be in a stroke. She brought me this little telescope, a little refractor.
Yeah.
I pointed at the moon, I see the craters on reasonably well. Back there, I could see mountains and shadows. And I thought it was like, I thought it was cheating. I thought somebody had drawn something at the end of the time.
You thought it can't look that good.
It can't look that good.
Yeah.
It's just staggering that we have this alien world on our doorstep.
It's amazing. I mean, whenever you show people at an astronomy open night, the rings of Saturn, often they've never looked to or like seen that in person before, and that's the sort of thing that leaves a real mark.
People, doesn't it?
Yeah.
Okay, well, let's talk about your undergrad in Australia.
I did. My research was at Space Telescope Science Institute, as I mentioned.
Were you located, or were you partially located in Hobart, or
only at the end? Of course, I moved to St Andrews, which is where we met.
We were very mature, but I wouldn't go. I would actually take the blame for this, because you were fairly sensible.
Oh, okay. That's very kind of you to say so.
Yeah, but I think what it was is tea time. Everybody else was so sensible, especially Keith Horn with his, talking about all his algorithms. I think you and I, while we were scientifically interested, we were a little bit bored, and so we just were silly.
Well, I'm a great believer in the law of averages. And so you see, if you find yourself around a bunch of boring people, then you find yourself having to counterbalance. That was our role.
Well, you're also a very funny man, which really helps. Because I can quiz you on this, because I know a little bit about this. Tell us about the main avenues of your research.
Well, this has been a meandering path, because, as I mentioned, my original inspiration in astronomy was largely rooted in planetary science. The planetarium, the Voyager 2 spacecraft, and also Venus, because there was an image which is on my wall over there. Maybe we can show the viewers later, but it's a painting of one of the Venera spacecraft, which was the Soviet space program. During the 60s and 70s and 80s, that program was very prolific with the Americans to claim Venus because they thought there might be life there. But the Venera 13 and 14 landers landed and took first color images from the surface of another planet and created this artist impression of Venera 14. So those are the sorts of things that inspired me going in. We tended to move forward in planetary science. At that same time, in the mid-90s, a new field was emerging. Now, when I say emerging, the search for planets around other stars have been happening for a long time, and there had been some successes. But in the mid-90s, it actually became accessible to do a PhD in this subject. Prior to that, it had been mostly people who had been trying to calibrate the instruments and get things like actually working. And so that opportunity came up, and I thought, okay, well, here's an infinite number of planets. It was interesting. Back in those times, in the mid-90s, the transit method of finding exoplanets was not seriously considered. And that was, it had been suggested numerous times, and God knows Bill Barucki, who ended up being the PI of the Kepler mission, he was very much advocating for it. But what held it back was the fact that a probability that a particular planet will transit, and well, that's not really viable. So at that time, people were thinking about working or had this potential to really produce mass results, and those were things like radial velocities and direct imaging as a kind of a stretch goal dream sort of thing. But microlensing was one of.
So you used a couple of fancy words there. So
Yeah.
radial velocities, that's the reflex motion of the star backward and forward as a planet is orbiting it.
Right, yes, and that had several successes, and it had produced the main success when I was applying to grad school in '95. That was, and that was discovered from not seeing the planet itself, but credible, we can do that.
This was the Ogle team, is that right?
Yeah, well, that Ogle team was looking for these events, and then would alert a follow-up team called Planet, Probing Lensing Anomalies Network. It was just an excuse to have Planet as your astronomy and acronyms. But I spent my life staring at these stars to see if there would be signature of a planet. It was only at the end of my PhD when the transit method all of a sudden was seen as viable, and we detected the transit of the known planet HD 209458b. A telescope just with a mounted camera sitting in a car park.
And I know, of course, I know the answer to this, but this is a really sort of question that general lay person or the lay astronomer wouldn't even think of. Why do you care about the transit method?
Because the transit method, well, particularly compared to the microlensing method, which is really a one-shot. Microlensing, the way I won't go into the details of the way in which that works, but suffices to say is that you only get one very brief insight into whether or not there's a planet there. Things like the radial velocity method and the transit method, you can continuously see the orbit of the planet. And in this case, the transit method has the planet passing between us and the star, and so we see the star get fainter for a brief period of time. Now, the reason that that's so cool is because from that we can extract a measurement of the radius of the planet
And the mass.
And well, so the radial velocity method gives you the mass. So the transit will give you a radius. You can then follow up, and then you have the mass. You have the radius and the mass. Bulk density of the planet. It opens up all sorts of things which we didn't fully appreciate back in 2000, because it turned out that it also is a pathway towards atmospheres, because as the planet passes between us and the star, the light from the star passes through the limb of the atmosphere, absorbs at some wavelengths, and so it opened up just an incredible amount of science. It's always been the issue that people had with the radial velocity method. The minimum mass then in principle, it meant that where that signature was actually being caused by a brown dwarf or even a low mass star, and we weren't really sure. Statistically, we knew that some of these have got to be real, but for an individual case, you always left with that question. Transits removed that question mark because, like you said, you knew the inclination.
Sinai is more or less 90.
Yeah.
Right. Yeah, I love that. I love the sort of mathematical closing the circle on that.
Yeah.
Well, so I know that's been so you and I that's how you and I met a team where we were doing right angle search for planets.
Yeah. I'm trying to remember what the original question was. I think it was what science do I do? So I promise I'm getting there. So then let's fast forward to the Kepler mission, and that was looking for transiting planets from space. And it was really pushing towards terrestrial planets. And the focus of the Kepler mission was finding an Earth-like or Earth-sized planet. And I very quickly realized, well, we have a twin planet, Venus, and Venus is the same size as Earth. And so I realized something else, which was that the exoplanet community largely did not know much about planets, which is extremely ironic. But the reason for it was because the main techniques that were being used were simply studying the stars. At that time, was almost entirely stellar astronomers. And so I thought, we need to do something about this. So at that time, I went back to, as I mentioned earlier, I was originally interested in Venus. So I thought, I'm going to just invite myself to Venus meetings. I didn't know anyone in that community at that time. And I just showed up to a meeting and then would give them a talk about the Kepler mission. And the interesting thing about that time is because, as I mentioned, there was a lot of missions to Venus in the 60s, 70s, and 80s. The last US-led mission to Venus was the Magellan mission, which was in the early 90s. But since then, they hadn't had a mission. Everything had been going to Mars. And so the Venus community was kind of a depressed, had very low morale. It was an aging community. And so I went to them and said, well, actually, there's an entire, very much growing community called exoplanetary scientists, and they need you. And so what you should be pitching is that Venus is an Earth-sized planet that is right next to us. So I started doing this sales pitch for this is why we need to go back to Venus. But through all of this, my interest was really, and this is the focus of all my research now, is planetary habitability. In other words, why did Venus and Earth turn out differently? And what are the factors that control the sustainability of surface liquid water or temperate surface conditions in general? And I look at all different aspects of that. I certainly look at Venus a lot and use that as laboratory, really, for studying terrestrial planet evolution. But even things like giant planets, how has Jupiter affected Earth's orbit through time, changed the climate through time, the effect of water delivery, the effect of the interior cooling, and try and connect all the pieces together. It's just an incredibly fascinating puzzle to me.
Yeah.
And I feel like Venus holds a lot of the keys to solving this.
It's very interesting you say this, Stephen, because of course the thing I've always thought about is with Jupiter as well, is it came from the same primordial soup that we did, the same protoplanetary disk. And so one might imagine for Venus the densities are very similar, given its mass and radius. These are not just the fact that you're the same size. I think the actual sort of chemistry is going to be similar as well.
Yeah, and one of the things that I think about all the time is how those similarities resulted in this divergence, because we're seeing Earth and Venus now after 4.5 billion years of evolution. But like you said, when they formed, they probably formed truly as twins. I think Venus may have been through an early period of surface liquid water. That's pretty profound, because it means that just because you have surface liquid water doesn't mean you always will. And things could go catastrophically wrong. So
in a place like California,
as Riverside is showing right now.
Venus A has a very slow rotation. One would imagine then you would get massive solar wind ablation. And the atmosphere of Venus is approximately 90 times the pressure of Earth's. So could you maybe make a comment about that?
Yeah, it's a very interesting problem. There's several things that you brought up there, which are definite differences between Venus and Earth. And we've only truly realized this in a quantifiable sense over the past decade or so, because that's when 3D climate models have allowed us to understand, well, what is the effect of rotation? And it has all kinds of effects on climate. For example, if you're a slow rotator, you have cloud formation on the day side, and that cools it down. And so you can have this pretty incredible effect. The relationship between rotation rate, the strength of the magnetic field, circulation of the atmosphere, and the evolution of the climate, because everything's connected. It's kind of like trying to solve a very elaborate Rubik's Cube where you turn one thing that's like you realize, oh no. But to answer your question about the atmosphere that we think about a lot right now in the context of exoplanets, in that terrestrial planet, which is very close to its star, then is it going to lose its atmosphere? And the solar wind and flares and so on. So Venus, it's lacking a magnetic field, or at least a significant one. The reason that it has a very thick atmosphere still seems to be largely because that the carbon dioxide atmosphere has a very high mean molecular weight. And we have done some simulations which show that it's actually really hard to shift a thick CO2 atmosphere, even if there's relatively low magnetic field. Yeah, it's an interesting problem.
Yeah. So this is again, it's a provocative question, but if you were to be talking to somewhere like Starbucks or Dunkin' Donuts, where I'm from in the Northeast, who cares?
Who cares about Venus? Well,
or planetology or astronomy.
Yeah, so that's such a fundamental question. He's spending federal money on this when when our hospitals need repairs and there's problems with the roads and schools and so on. And I think that it's incredibly fundamental endeavor for the human spirit. It's kind of like asking about, well, why don't we just close down all the museums? Why don't we just get rid of all music? Why don't we all funding of the arts? Yeah, sure, you could do that and save a tiny amount of money that you wouldn't even notice. But what would we have lost as a society, as a culture, as a species? And the answer is we would have lost everything that we're fighting for. And so the reason that we should do all of this is, I think, fundamentally to advance human knowledge, to expand our realization of our place in the universe, about the history of Venus, which I think is incredibly important. But it teaches us a lot about Earth's past, but especially Earth's future, because one of the ways to look at Venus is kind of a preview into a possible future of Earth. If we don't understand how Venus turned into its current state, then that means we have no idea that we will not follow. And once we understand that, then that gives us incredible amount of guidance for understanding habitability. So there's many different levels of this, but ultimately I think that we should be doing this just for knowledge's sake.
No, I get 100% agree.
It does inspire a lot of people, but not necessarily to become astronomers, to do all kinds of things that contribute to science. And so our country, the United States, sees a lot of return on that investment. And it's hard to track that. It's hard to quantify, but because you see this at astronomy open nights, I think we have it fairly fortunate that we're able to capture the imagination more so than many other sciences.
Especially, I like the tack you took there of Venus, because of course there are discussions going on right now with Earth in terms of global warming and climate change. And one thing I've always thought about, and of course you're the expert in this, especially planetology, is the difference between there's the political aspect of climate change and then there's the scientific aspect. And people will say, I don't believe in Well, of course, the beauty of science is you don't have to. Can deny climate change if you wish. I think the evidence is overwhelmingly conclusive, especially with Venus and Mars raised.
Right.
But the mathematics you use to do that is the exact same mathematics opticians use to make these glasses. The same science that we use to make the mobile phone that we're recording this video on.
Yeah.
Same as your Tesla car that you might drive home, or your flashing gizmos over there. All of the science that is required to make all the toys we have in society is identical. It's 1 + 1 = 2 and 1 - 1 is 0. That's the foundation. Everything else is built upon that.
Yes.
So I think these people who are climate deniers, or people who say, I don't believe it, and of course you're allowed your own opinion, but it's not as if you're making up fancy science or like we're making up new religion.
Yeah, and a lot of the science that we're talking about, fundamentally, like for example, if we're talking about the invention of charge-coupled devices and electronic detectors, and it's really about the absorption of photons. The absorption of electrons. No, I meant what I meant first time. The absorption of photons.
Yes.
But that's the same sort of stuff that we talk about in climate science here. It's about how different molecular species absorb, and so it's all based on the same fundamental science. Yeah.
Well, there's even that sort of old wives' tale science as well. Is that on a clear night, especially somewhere like here in Riverside, California, Southern California, it gets probably pretty chilly. If it's cloudy, it probably stays more temperate because that water vapor is re-emitting the infrared that it's absorbed to make the water vapor molecules rotate and vibrate.
Yeah.
So you feel a cloudy night is warmer. So even just colloquially, like the old fishwives tales, it feels warmer on a cloudy night.
Yeah. Yeah, the only difference is now we can quantify that now and model it and extrapolate and make predictions.
Yeah. So that sides to being an astronomer or professional educator.
Oh, for sure.
Quite. That's what today's for.
Well, I think the probably the number one downside has to be the career uncertainty. Yeah, a lot of people struggle with that, especially now, and it's one of these difficult things where even if you're passionate about it, it always pays to have a backup plan in your back pocket. You know, in our field, it can be something which you receive pressure from whoever your boss at the time, but especially from yourself, because when you finish, if you say, all right, I'm going to finish at 5 p.m., I'm not going to work on the weekend, I'm not going to do any of that. Well, you know that you're going to be competing on the job market with people who are working out to 5 on the weekend. So what are you going to do about that?
I was program manager for this awesome group and was able to, we're allocating big money to all these telescopes around the world to coordinate the radio telescope campaigns. But I really struggled with the fact that I had young children at home, youngest children, all of them.
Yep.
Wanting to balance that, wanting to still play a bit of sport, have a love life, go to the cinema, but also the negativity coming from leadership, or at least one or two specific people in that collaboration, really soured a strong for me, actually.
Yeah.
So then I thought, why am I doing this? You know, I don't mind writing an email when the children go to bed, or writing a report to the National Science Foundation. But if I'm also having to do these unreasonable things for an unreasonable person, why? And that's sort of really what drove me out.
It is, and for me to maintain my research group, I've got a lot of mouths to feed, so to speak, and so I have to spend a lot of my time outside of regular hours working on that, making sure, because the alternative, frankly, is something that I don't want to face.
No,
I never want to have to go to people in my group and say, well, I don't have the money for that. Yeah, so that's what I think is the most difficult. Yeah.
It's never going to say on your tombstone, God, he was a hard worker.
You're right. Yeah.
You don't want it to say that. A decent person, you raised a good family and you treated your wife well.
Yeah. Yeah.
That's a tough one.
Yeah.
All right, that's really cool things about being an astronomer or an educator.
Subject. You get to be at the forefront. And especially when you're research, to be learning things that you know known before. Like this is brand new, and you hold that, and then you do your colleagues, and then you go to conferences and give talks. You go to the media and you disseminate that to the public, bringing that excitement out. Because I give a lot of public talks, and I love inspiring people. Hearing the excitement from people when you do one of these careers that every now and again you'll say, "Am I really doing this?" Yeah, for sure.
Yeah, still. Well, I think for me, the field I grew up in, which was open clusters, that's rotation and lithium and magnetic fields at solar type stars. For me, that passion's always going to be there. It's actually very, very high. So even now, I look at the Messier 7, which is at the center of toward the center of our galaxy, with my thesis cluster. And apply these. Makes me still go, oh my god, I'm so proud of that. Really cool.
This is what 10-year-old me was, and it's always about keeping that in mind.
Yes. Yeah. Just the sheer pleasure of doing it.
Yeah.
Awesome. Yeah. I tell my children that, I say, if you can ever find something you're that passionate about, that it does all light work, you've won. You've won the game of life about.
That's the key. Yeah. That's the key. Yeah.
Well, I really like that.
Yeah.
All right, this is a hard one. This is philosophical.
Oh, yeah.
Hit me. What would you tell your younger self on the journey that you took to become a professional scientist?
That is a hard one.
A tough one, isn't it?
That is a tough one. Yeah. But actually, I think it's related to what we were just talking about. Because going through the process of making a career out of this has many, many challenges and many, many moments of anxiety. And am I going to be able to get a job? And and obviously the work, the learning curve. I mean, especially when you're early career, you're often just thrown in the deep end. Somebody will sit you in front of a telescope and say, "Figure it out." Yeah. I remember the first time I went to CTIO. I was a first-year grad student, and I went to the control room on the first night. Folder in front of me and said, "Read this. We'll start tonight." Yep. It's just it can be very daunting, a lot of anxiety, but the rewards are fantastic. And as we're just saying, what we're doing now is what our younger self dreamt of. Yeah. So going back and talking to my younger self, I would say never lose sight of the passion. Even at those times, especially at those times, remember why you're doing this. Because if at any point this just starts to feel like, I'm just looking at a spreadsheet here or just like managing a team. To be honest, it's one of the reasons why I've always resisted the pull into upper management, because there is somewhat of an expectation once you get to this career stage. Like people ask you all the time, and I often get asked to be department chair. When these moments happen, I have to sit back and think to myself, well, what would 10-year-old Stephen want me to do here? Do I want to end up in a position where all I'm doing is like looking at spreadsheets or doing it? Never lose sight of why I wanted to do this in the first place, which was to do really cool, amazing things. And so I would just tell myself to keep your eye on that.
You remember why you did it?
Yes, remember why you did this. It's
very funny. I like the biggest part I liked about that story was, I feel exactly the same. It was the very first time I went to observe on a professional telescope was in South Africa.
Yeah,
I say South Africa astronomer observed in the Karoo. And my PhD supervisor, Roderick, was at the time, had developed non-Hodgkin lymphoma, so he had cancer. And so he said, "Look, I can't travel." And this was just into a year into my PhD. International travel, but to use a real telescope was just like. So we had 2 weeks. Well, first week was on the 1.9 meter with a spectrograph, and we were looking at M dwarfs with the look at H alpha to see if they were active. But we detected the old ROSAT satellite. They were all X-ray detections. And then the second week was to do photometry of Messier 7, this yellow open cluster to orbital axis. So Gordon was, a pretty high up guy, and he was teaching and had to run the department. So he comes down for the first week. We had this phenomenal week on the 1.9 meter. I learned an awful lot about spectroscopy and M dwarfs and telescopes, and it's like I'd won the lottery. And Gordon's such a nice patient guy, just a super mentor. And I was literally, I thought I'd won the lottery. Happiest I'd ever been professional.
Yeah.
And the second week,
as I mentioned earlier, I worked with Kailash Sahu when I was at SDSCI, and before my first run down there, he always said to me, when you come home, always make sure that you have your data in your pocket. Because back in those days, a lot of these observatories didn't have high-speed internet. And so if you left the data on the machine there, it was gone. And you couldn't just log in and grab it. So.
Well, this was obviously for me 30 odd years ago. I was paranoid about it, and I would leave a copy on an exabyte or on reels at the observatory.
Yeah.
Satan, this is a really great episode, and I really love that we were taking a long time because we talked about a million things. But we're about the last question. Now, you're still a young man, you're not quite Gandalf. Where do you hope to see yourself or your science in 10 years' time?
In 10 years' time, well, of course, hopefully Da Vinci will have been successfully deployed on the surface of Venus, and that will just be a magical moment. So, there's a lot of excitement coming. And so after that, applying those data to models of terrestrial planet atmospheres. And so I would, in 10 years' time, I see myself hopefully basically doing what I'm doing now. But with better input data. Yeah, I think that's going to be very, very exciting. So there's going to be a lot of there's going to be so many things happening at that same time. There's going to be missions like Europa Clipper will have seen orbital insertion. So there's a lot of good things coming up, and I look forward to seeing those data in the years ahead. Yeah. I think it's going to be great.
Oh yes, so excited. Well, this will leave it so long next time.
Yes, for sure.
This is obviously you and I've always gone pretty well with our childish sense of humor and the great.
Oh, I don't know what you're talking about.
Yes.
A little bit.
Give me up to today's girls.
Yes, of course.
Let's leave it so long. I'm hot chocolate or who knows, a beer at some point.
Yeah.
This has been a thorough pleasure, Stephen.
Thank you very much. You're welcome anytime.